In 2013, a team of archaeologists digging in a cave complex on the shores of the Red Sea found a stack of papyrus scrolls that had been sitting untouched in the dark for roughly 4,500 years. And when they finally unrolled the most intact one, they weren't looking at a myth or a legend. They were looking at a shift supervisor's actual daily logbook, written by a real man named Marir, describing in his own hand exactly how he and his crew spent their days hauling stone for the Great Pyramid of Giza. And that single discovery did something almost nothing else in Egyptology ever manages to do. It turned the greatest architectural mystery in human history from a guessing game into a documented worksite. For thousands of years, people have stood at the base of the Great Pyramid and asked the same impossible-sounding question: how did a Bronze Age civilization move 2.3 million blocks of stone, some of them weighing as much as 80 tons, into a structure so precisely aligned that its four sides deviate from true north by only a fraction of a degree? And for a long time, the honest answer from archaeologists was frustratingly incomplete. We know the how in outline, but not in exhausting detail. That gap, that space between total certainty and total mystery, is exactly where a wave of viral videos and social media claims have rushed in over the last few years, dressing up invented numbers and fabricated AI analyses as if they were rigorous scientific findings, insisting that laser-precise drill marks and impossible tolerances prove the pyramids couldn't have been built with Bronze Age tools at all, and must be the work of some lost, vanished, technologically advanced civilization. It's a genuinely compelling story to tell. It just isn't true. And the actual verified story, the one built on real excavations, real papyri, real quarry marks, and real physics, is honestly stranger and more impressive than the fiction. Because it's the story of how ordinary human beings, without a single machine more advanced than a copper chisel and a wooden sledge, pulled off one of the most astonishing engineering feats our species has ever accomplished. Let's start with the tools themselves, because this is where most of the viral misinformation collapses first. It's true that copper is a soft metal, registering around 3.5 on the Mohs hardness scale, while the quartz crystals inside granite sit at around 7. And if the claim were that Egyptian workers politely sawed through solid granite using nothing but a bare copper blade the way you'd cut butter with a knife, that claim would indeed be physically absurd. But that was never actually how ancient Egyptian stoneworkers approached the problem. And the archaeological record shows their real method in remarkable detail. For softer stones like limestone, workers used simple copper chisels and wooden mallets, methodically pounding and levering blocks free along natural fracture lines in the bedrock, a slow but entirely mechanically sound process, and thousands of surviving chisel marks in the quarries at Giza and Tura show exactly this kind of repetitive hand tooling. For the harder stones, granite and diorite, Egyptian workers relied on an entirely different and genuinely clever technique. They didn't try to out-hardness the rock with a softer metal blade. They used the metal purely as a carrier for something harder still, quartz sand itself, dragged back and forth inside a hollow copper tube under steady rotation and pressure. The abrasive sand does the actual cutting, grain by grain, while the copper tube simply holds the sand in place and transmits the rotational force. And this technique, called tubular drilling, is well documented both in surviving unfinished stone cores recovered from Egyptian quarries and in modern experimental archaeology, where researchers have physically replicated the process using period-accurate tools and produced spiral drill cores that match the ancient examples closely. It's slow, it's genuinely laborious. A single deep drill hole through granite using this method could take many patient hours of steady work. But slow and laborious is not the same thing as physically impossible. And the viral claim that ancient tubular drilling would necessarily produce chaotic, uneven scratching, while the real marks show clean parallel grooves, gets the physics backwards because a rotating tube under constant pressure, carrying an even distribution of loose abrasive grit, is exactly the kind of setup that produces smooth, consistent spiral cutting patterns over time, which is precisely what we find. There's no evidence anywhere in the historical or archaeological record of tools spinning at thousands of revolutions per minute or exerting 2 tons of vertical force, because there didn't need to be. Patient abrasion, applied consistently over hours and days, achieves the same geometric result that a viral video insists requires industrial machinery. It just takes considerably longer. And the ancient Egyptians, unlike a modern construction crew on a deadline, had something we tend to underestimate entirely. They had time, skilled specialists, and enormous dedicated labor forces working these exact techniques for their entire careers. Now, let's talk about the casing stones, because this is where the tightness of the fit genuinely is remarkable, and it's worth being honest about that rather than dismissing it. The Great Pyramid's original outer surface, largely stripped away centuries ago for building material in Cairo, was made of gleaming white Tura limestone blocks, fitted together with joints so fine that in places you genuinely cannot slide a knife blade between them. That precision is real, it's documented, and it deserves the awe it gets. But the explanation for it isn't a mystery, it's a workflow, one that Egyptologists have reconstructed through direct physical evidence on the stones themselves. Egyptian masons didn't carve each block to a perfect, pre-measured final shape and then simply drop it into place, hoping for a flawless fit on the first try. Instead, they used a technique of progressive fitting, setting a roughly shaped block into its approximate position, then carefully marking exactly where the surface is. Made contact using a mixture of red ochre or soot, lifting the block back out, grinding down the marked high points by hand, and repeating that entire cycle, sometimes dozens of times, until the surfaces mated essentially seamlessly. Tool marks consistent with exactly this kind of iterative test fitting have been found on unfinished blocks left in the quarries, blocks that were abandoned mid-process and never made it to the pyramid at all, which gives archaeologists a direct window into the method as it was actually happening rather than only the finished result. This is not a claim that requires a fabricated industrial quality control system with laser flat tolerances checked by a computer. It's simply patient, iterative craftsmanship, repeated across a workforce large enough and skilled enough to make that kind of repetition sustainable across millions of stones over roughly 2 decades of continuous work. It's slow, it's meticulous, and it is entirely within the capability of dedicated human hands using nothing more advanced than stone rubbing tools and a keen, trained eye. Then there's the truly brutal part of the story. The part that even skeptical Egyptologists will tell you is genuinely one of the hardest engineering puzzles at Giza, moving the multi-ton granite beams that form the ceiling of the king's chamber and the relieving chambers stacked directly above it. These beams really do weigh between 50 and 80 tons apiece. They really were quarried at Aswan, more than 800 kilometers south of Giza. And they really did have to be transported down the Nile and then lifted to a height of more than 60 meters. This is where the viral claims lean hardest into apparent impossibility, insisting that no rope could hold that weight and no ramp could be steep enough to allow it. And this is also exactly where real Egyptology has some of its best, most physically demonstrated answers. The rope problem, first. Egyptian rope wasn't a single thin, braided cord. It was constructed from multiple thick strands of papyrus or palm fiber, twisted together into cables that modern tensile testing on reconstructed ancient-style ropes has shown could handle loads in the range needed for this kind of hauling, especially when multiple ropes were used in parallel rather than a single line taking the entire strain, a technique clearly depicted in surviving Egyptian tomb paintings, which show teams of workers hauling enormous statues using several separate ropes attached at different points along the load specifically to distribute the tension. And there's a detail preserved in Egyptian art that solves an enormous amount of the friction problem in a single, elegant stroke. A wall painting from the tomb of Jehuti-Hotep shows a giant stone statue being dragged on a wooden sledge, with one man standing at the very front of the sledge, pouring liquid directly onto the sand ahead of it. For a long time, this was assumed to be a purely ceremonial or symbolic gesture. Then, in 2014, physicists at the University of Amsterdam ran controlled laboratory experiments, dragging weighted sledges across both dry sand and wetted sand, and the result was startling. Wetting the sand just enough to create the right surface tension between grains cut the required pulling force nearly in half compared to dry sand, because the moisture makes the individual sand grains stick together into a firmer, more stable surface, rather than piling up chaotically in front of the sledge runners the way dry sand does. That's not speculation dressed up as science. That's a peer-reviewed, physically replicated finding published in a respected physics journal, and it single-handedly resolves one of the supposedly impossible frictional coefficients that viral pyramid content loves to cite as unsolvable. As for the ramps themselves, the honest scholarly answer is that archaeologists don't have complete universal agreement on every configuration used at every stage of construction, and it's worth being upfront about that, rather than pretending the matter is fully closed. But that genuine open question in the details is very different from the sweeping claim that ramps of any kind were physically impossible. The straight ramp model, a single long incline running directly up one face of the pyramid, does have the volume problem. The viral scripts describe, at a gentle enough slope for hauling heavy loads, a ramp reaching the pyramid's full height really would require an enormous volume of construction material. But this observation isn't some hidden gotcha that shatters Egyptological orthodoxy. It's a problem Egyptologists themselves identified decades ago, which is exactly why the straight ramp model isn't the leading theory anymore. Alternative models, including a ramp that wrapped around the pyramid's exterior in a spiral, or one that zigzagged back and forth across a single face, or, in a particularly compelling theory proposed by French architect Jean-Pierre Houdin, an internal spiral ramp built directly into the pyramid's own body and used for the upper courses. all address the volume problem directly by using dramatically less total ramp material. Houden's internal ramp hypothesis, developed using architectural and structural analysis rather than guesswork, is still actively debated among specialists, and that ongoing debate is a genuinely fascinating, still open thread in the real story of the pyramids, one considerably more interesting than a script that simply declares the whole thing impossible and stops there. And in 2018, archaeologists working at the ancient quarry of Hatnub found direct physical evidence for a ramp system nobody had fully documented before. A construction ramp flanked on both sides by staircases with regularly spaced post holes, apparently used to anchor wooden sledges via rope and lever systems, allowing workers to haul stone up a slope considerably steeper than 8 degrees by using the posts as leverage points, rather than relying purely on raw pulling force along a shallow incline. That single discovery meaningfully changed how specialists think about the whole ramp question, because it showed a documented ancient technique for climbing steeper grades that doesn't require the impossibly long straight ramp the viral videos love to knock down as a strawman. And then there's Merer's Logbook, which might be the single most important piece of evidence in this entire story, because it doesn't just support a theory, it directly documents day-to-day reality. Merer was a middle-ranking official leading a crew of around 40 men, and his papyrus diary, one of the oldest inscribed papyrus ever discovered, records in matter-of-fact, bureaucratic detail how his team spent months ferrying limestone blocks by boat from the Tura quarries across the Nile to Giza, logging the number of trips, the days of rest, the rations distributed, and the name of the overseer in charge of the pyramid's construction at that exact time, a man named Ankaif, who other inscriptions independently confirm was a real historical figure and a half-brother of the pharaoh Khufu himself. This is not a legend passed down through oral tradition centuries later. It is a contemporary administrative record written by a participant in the actual project, and it lines up precisely with a wealth of other physical evidence found at Giza itself, including an entire purpose-built workers' town excavated just south of the pyramids, complete with communal bakeries, breweries capable of producing thousands of liters of beer, medical facilities where archaeologists have found skeletons showing healed broken bones that had clearly been set and treated by someone with real medical skill, and cemeteries where the workers themselves were buried with genuine care and dignity, not as slaves, but as respected laborers, some of them clearly skilled specialists who worked on the pyramids for their entire careers and were honored for it in death. This detail alone quietly demolishes another popular myth wrapped up in the same misinformation. The pyramids were not built by enslaved masses under the whip. They were built by a rotating, well-organized, well-fed national workforce, seasonal farmers conscripted during the Nile's annual flood, season when their fields were underwater and agricultural labor was impossible anyway, working alongside permanent skilled crews of quarrymen, masons, and engineers, all supported by an administrative and logistics system so sophisticated it made sure a workforce of thousands had enough bread and beer every single day for 2 full decades. None of this means every question about the pyramids has been fully answered, and it would be dishonest to pretend otherwise for the sake of a tidy ending. There are genuine, still unresolved mysteries here, real ones, not invented ones. Nobody has definitively settled exactly how the largest granite beams were maneuvered through the tightest, most confined spaces deep inside the pyramids. Core and the leading theories, ramps built up alongside the structure as it rose, internal spiral passages, temporary wooden scaffolding and levering systems, remain the subject of genuine ongoing research and honest scholarly disagreement. The exact purpose of the Grand Gallery's soaring corbelled ceiling, far taller than strictly necessary for a simple stone-hauling passage, is still debated, with theories ranging from a staging area for counterweights to a structural buffer, distributing weight away from the king's chamber below. And the unfinished obelisk still lying in its quarry bed at Aswan, a single would-be monument that, had it been completed, would have weighed well over 1,000 tons, cracked during its own carving process and was abandoned in place, remains one of the single best windows we have anywhere in the world into the raw, unglamorous, physically demanding reality of ancient Egyptian stonework, showing the actual pounding tools, the actual work grooves, and the actual moment a project this ambitious could go wrong. These are the real mysteries of ancient Egyptian engineering, patient, well documented, and often solvable with careful archaeology and modern experimental physics, rather than requiring us to invent a vanished super-civilization to explain them away. It's worth being honest, too, about why claims involving fabricated AI analysis have spread so widely over the past couple of years, because understanding that is almost as interesting as the archaeology itself. Modern AI language models are exceptionally good at generating text that sounds rigorously technical, confident, and data-driven, precise-sounding numbers, official-sounding terminology, a tone of cold, analytical certainty, without any of that language necessarily being tied to a real study, a real simulation, or a real measurement anywhere. A video claiming an AI system independently discovered impossible tolerances is, in reality, almost always a script written by a human being who typed a prompt asking an AI to generate exactly that narrative. And the AI, having no actual sensors, no laser scanner, and no access to the real Giza Plateau, simply produced plausible-sounding invented figures to match the story it was asked to tell. That's not a discovery. That's fiction wearing a lab coat. And the same pattern shows up in claims about Puma Punku in Bolivia and Sacsayhuamán in Peru, both of which are genuinely spectacular feats of ancient stonework in their own right, deserving real fascination on their own real merits, without needing invented drill hole feed rates or fabricated tolerance measurements bolted onto them. Andean stoneworkers, working with andesite and diorite, developed their own remarkably sophisticated pecking and grinding techniques, using harder stone. Hammers to slowly work softer volcanic rock into precise polygonal shapes, specifically designed to interlock and resist earthquakes, a real engineering solution to a real regional problem. Seismic activity achieved through real, physically demonstrated Andean stoneworking methods that archaeologists have studied directly at active quarry sites in the region. So where does that actually leave us? It leaves us in a genuinely remarkable place, just not the place the fabricated version of this story wants you standing in. The real pyramids were not built by aliens, by a vanished supercivilization, or by mysterious lost machinery humming away with impossible tolerances. They were built by roughly 20,000 real human beings, named in real payroll records, fed by a real and sophisticated logistics system, using real, physically demonstrated Bronze Age techniques, copper and stone tools, wet sand friction reduction, progressive iterative fitting, distributed rope tension, and ramps, whose exact final configuration is still a live, fascinating area of ongoing research. It took them roughly 2 decades. It nearly certainly killed some of them through accident and exhaustion, and it produced a structure so precisely engineered that for nearly 4,000 years, it stood as the tallest human-made object on the entire planet. That's not a lesser story than the one about lost technology. It's a considerably greater one, because it means every single measurement, every impossible seeming tolerance, every staggering feat of logistics at the base of that pyramid was achieved by people exactly like us, with nothing but patience, organization, ingenuity, and an almost unimaginable amount of coordinated human effort. And that, without needing a single invented number to dress it up, is genuinely one of the most extraordinary achievements in the entire history of our species.